All right, here is the video for lesson 4.03a, independent practice. We're going to be working with cubic roots and square roots. Here's an example, problem number one. I did a similar one. This is called a cubic root, this problem that I wrote here, because this little number here is called the index of the radical. So this little number is called the index. This symbol here is called the radical, or sometimes they call it root. Okay, that's another name. And when the index is 3, we call the radical cubic root. That's how we call that, cubic root. Okay, and basically what we want to find out when you see one of these type of problems with the radical symbol and the little 3, imagine you have a cube, and inside the cube you have the number 216. You want to find out how much is each side of the cube. So when you multiply 3 times by itself, so what number multiply 3 times by itself, it will give you 216. That's what cubic root is. And the easy way is, if you remember this table here, at some point you're going to have to memorize. And because my index is 3, I'm going to be working with the green column, the perfect cubes. And what I'm going to do is I'm going to look for the number 216. And you can see 216 is right there. And in which row is 216? Oh, in row 6. Okay, so it means that each side here of this cube, if you multiply 6 by 6 by 6, that's how you get 216. So the answer here will be 6. Okay, let's try another one. Problem number 2. Here is question number 2. Now we are working with what is called square roots. When you do not see a little number up here, by the way, the number that we write on the yellow section, we call it the index, like I told you in the previous problem. When you do not see a number there, it's because the number that is there, the index, is really 2. And when the index is 2, we call the radical, remember this symbol, we call it the radical, or we call it also root, okay? We call the radical square root, okay? And the way you do square roots, you're gonna imagine a square, and inside the square, you have the number 121. And remember that all the sides of the square are the same number. So you want to find out what number multiply 2 times by itself. It will give you 121. And there's an easy way of doing this. If you had the table, like I'm showing you on the right-hand side, because the index is 2, I'm going to be working with the column in blue, perfect square. We're going to look for 121. You can see that 121 is right here. So in which row is 121? Row 11. That means that each side of this square is 11, or that 11 times 11 is the one that gives you 121. So the answer here is 11. Okay, let's go to the next one. All right, and the next problem, problem number 3, they gave us the cubic roots of 351. I'm going to do one similar. Here's what you're going to do. Remember, when the index is 3, we call this little number the index. When the index is 3, we're working with cubic roots. That's how we call it. We're working with cubic roots. And basically, I'm thinking like a cube, and what number, in fact, the number 108 is inside the cube. And I want to find out what number we multiply 3 times by itself. The edges of the cube are exactly the same length. So what number multiply 3 times by itself? It will give you 108. Okay, now one way to find that out is you're going to take this number 108, and you're going to see if it's in the table here in the section that is in green. Why in the green? Because those are the cubes. Okay, perfect cubes. The index is 3. We call it cube. So we're in the green section. Now look for 108 in the green column. And you're going to notice that 108 is not there in the green column. So that means that 108, this number is not perfect cube. It's not a perfect cube. All these numbers in the list, in the table, in the green column, they're called perfect cubes. You can see the title there. So 108 is not a perfect cube. So what we're going to do is we're going to do a tree. Okay. If you forgot this from sixth grade and seventh grade, we're going to tree. I want two numbers. When you multiply, it will give you 108. You cannot use 1. You cannot use the 108 itself. Okay. So it could be any numbers, any two numbers, as long as not 1 and itself. So I'm thinking like 2 times 54. See, if you divide 108 by 2, you get 54. Then I'm going to try to do a tree with a 2. But 2, there's no number, there's no two numbers that can make 2 other than 1 and 2. But I'm not allowed to use 1 and the number itself in the tree. So that's what I'm going to circle it. Now, when I circle that, we call that a prime number. Okay, that's how we call those numbers I circle. Prime number. 54, I can find two numbers that make 54. 6 times 9. Okay, and then 6, I can do a tree because I can make 6 using 2 times 3. I already know 2, we cannot make a tree. 3, we cannot make a 3 because the only numbers that make 3 is 1 and 3. I'm not allowed to use 1. I'm not allowed to use 3. And 9, that's the same thing if I use 3 times 3. And I already know 3 are prime. Now, how do you know when you're done with the tree? All those numbers that are hanging, if you circle them, that's how you know when you stop making the tree. Okay? And look what I'm going to do now. Let me erase this here. Now, I want to find out from the numbers that I circle, what number is repeated 3 times, because that's my index. And the number repeated 3 times are the 3s. See, I have 3 3s. So the 3 is repeated 3 times. And that's the number. What I'm going to do with the number that is repeated 3 times, I'm going to write it. See, I wrote 3. That's the number repeated 3 times. And the numbers that are left over, and what numbers are left over here? These two 2s. You're going to multiply them. 2 times 2, that will give you 4. So that, you're going to write it inside the cubic root. So I'm going to put 4 in the inside. Okay, let me write this index. Let me fix this. Remember, we're working with cubic roots, so I had to keep that little number there. And this is my answer there. Okay, this is how you do this problem. Let's go to the next one. Here's problem number 4. Same idea. They gave me the cubic root. Remember, when the index is 3, we call it cubic root. So basically, imagine that 128 is inside of a cube, and you want to find out what number you multiply 3 times by itself. It will give you 128. Now, the easiest way of doing this, you're going to look at the list on the table on the right side. And you're going to go, because my index is 3, I'm in what is called perfect cubes. I'm in the green column. And what I'm going to do is I'm going to look for this number, 128, in the column. And you're going to find out that 128 is not there. So what does that mean? That 128 is not a perfect cube. Not a perfect cube. And when it's not perfect, we're going to have to do the tree, like I did in the previous problem. So I'm going to make a tree with 128. And remember, a tree is, think of two numbers. When you multiply, it gives you 128. but you cannot use 1 and you cannot use the number itself. So for example, when I see this, I'm thinking of 2 times 64. Okay, and then 2, I cannot do a tree because the only numbers that make 2 when you multiply is 1 and 2. So instead of making a tree, I'm going to circle it. This is what we call a prime number. Now I'm going to go 64. I'm going to do a tree. 2 numbers when you multiply make 64. Oh, that would be 8 times 8. Okay, 8, I can do a tree. That's same thing as 2 times 4. I already know 2, I cannot do a tree, but 4, I can. So 2 times 2, okay? So I already know 2's, I cannot do a tree. The other A is the same thing as this one, so I'm going to write again 2 and 4, circle the 2, the 4, I do the tree, that will be 2 times 2. If you look, all the numbers that are hanging, I circle them. Okay? Now look what I'm interested. I'm interested in, looking at the numbers you circle, what numbers repeated 3 times. Look, these that I put in yellow, they're repeated 3 times. The 2 repeated 3 times. So I'm going to start writing my answer here. So let me erase this here. So my answers start looking like this. I have 3 2's here, so I'm going to put a 2 because that 2 is repeated 3 times. Times, if you notice, I have another group of 3 2's right here that is also repeated 3 times. So I have another 2 repeated 3 times. Why I'm interested in 3 times? Because that's my index. The index tells you how many times you want a number repeated. And then if you notice, there is no other number repeated more 3 times. So the only thing I have left is the 2. So that 2 that I highlighted in blue, I'm going to put the radical, I'm going to put the index, and that 2 that is left over, okay, I'm going to put it in the inside of the radical, okay? And then the last thing I'm going to do is I am going to multiply these 2 2's, and that's how I get 4, and then I say cubic root of 2. And that will be my answer there. Okay, let's go to the next one. In question number 5, we're working with a different root. When you do not see any little number up here, the index, it's because the number that is there is an invisible 2. When the index is 2, we call it square root. Okay? When the index is 2, we call it square root. So imagine a square where inside the square you have 28 and you're looking for a number. Remember, all the sides of the square are the same. Okay? If you're looking for a number that when you multiply 2 times by itself, it will give you 28. Now, one easy way of doing that is you're going to look at the table on the right, go to the column in blue, because those are called perfect squares, and that's what we're working. We're working with index 2. And try to see if 28 is in the blue column. And you're going to find out 28 is not in the blue column. So what does that mean about 28? It's not perfect square. It's not perfect square. Okay, it's not, because it's not in the list, in the blue column. Okay, so what you're gonna do, you're gonna do the tree. Okay, give me 2 numbers. When you multiply, it makes 28, but you cannot use 1, you cannot use 28. Any other 2 numbers. So 4 times 7. See, you're gonna have to remember your times table. Now 4, I'm gonna see if I can make a tree from using the 4. Yes, 2 times 2. And 2, we cannot make a tree because the only numbers I can make 2 is 1 and 2, but you're not allowed to use 1 and the number itself. So I'm going to circle it. Remember, the numbers that I circled are called prime numbers. And this other 2 I'm going to circle. And then the 7, I'm going to try to do a tree, but you're going to find out very soon you cannot do a tree with 7 because the only numbers that make 7 is 1 and 7. So I'm going to circle it. And the moment you circle all the numbers that are hanging, you're done, okay? And now we are ready to do the square root of 28, that is not perfect, the following way. The index 2 means that you want a number. Look at the numbers that are circled. You're looking for a number repeated 2 times. And I hope you notice the 2 is repeated 2 times. So that's why my answer, I'm going to put 2 because the 2 is repeated 2 times. But there's no other number repeated 2 times. So what I have left is the 7. And what I do with that 7, I'm going to put it inside the square root. So I'm going to put the 7 inside. And that will be my answer. Okay, that's how we're going to simplify the radical. All right, let's go to the last one. So here's a similar question to question number 6. If I mistake, yep, 6. Okay. And we are simplifying radicals. Again, we need to find out who's the number here, where I shaded in blue. We call that number the index. When you do not see a number, it's because the index is an invisible 2. We call that number again the index. And when the index is 2, we call this radical square root. Okay? And basically, you're going to imagine a square where inside the square you have the number 128. And you're looking for a number. Remember, all the sides of the squares are the same. You're looking for a number. So when you multiply 2 times by itself, it will give you 128. See? Looking for a number, multiply 2 times by itself, it will give you 128. All right? Now, the easy way of doing that is you're going to go to the table over here on the right side and looking at the column in blue. Why I'm looking at that column? Because those are the square, perfect square numbers. And what you're going to do is you're going to look for 128. And when you look at the blue column, 128 is not there. So what does that mean? 128 is not perfect square. So what we're going to have to do, we're going to have to do the trees. We're going to branch out 2 branches. Let's think of 2 numbers. When you multiply, it gives you 128. I don't know. I'm thinking of 2 times 64. Okay. I know 2, I cannot do the tree, but 64, I can. 8 times 8. Okay. And 8, I can do the tree. That will be 2 times 4. And 4, I can do the tree. That will be 2 times 2. Okay. And 8, I have another 8, so I'm just going to repeat the same tree. So 2 times 4. And then the 4, 2 times 2. When you're done circling all the numbers that are hanging, you're ready to do the square root of 128. Okay? The index is 2. That means I want a number repeated 2 times. Look, this 2 here is repeated 2 times. So my answer, I'm going to start having a 2 because the 2 is repeated 2 times. But if you keep looking, I have another 2 that is repeated 2 times. Okay? So this 2 here is also repeated 2 times. So I have another 2. Now remember, you're multiplying whatever number is repeated twice. Now, do I have more 2's repeated 2 times? Yes. Look, right here. These 2 are repeated 2 times. So I have another 2 here. Now, if you look closely, there's still a number inside a circle I haven't highlighted, which is the 2 I highlighted in yellow. This is the one that is left over. This is left. Okay, so the number that is in the circle that is left over, we're gonna write it inside the radical. See, so I'm gonna put it inside, and then what I'm gonna do last is I'm gonna multiply these 2's. And when you multiply those 2's, you get 8, and we keep the radical with the 2 inside. And this is how you do problem number 6. Okay, I hope this helps.